scheduling. So previous lesson, you have got a clear idea regarding basic concepts behind IPC. What is IPC? Inter-process communication, and the applicability of IPC. And also you obtain a basic knowledge on deadlocks. So when you try to communicate between processors, there can be deadlock situations. So we need to avoid those. Therefore, from this, you will be able to learn different types of schedule and different scheduling algorithms used in a computer environment. To avoid the deadlocks and other such problems, we need proper schedule. That's why we are going to learn about this. So, scheduling of processes. So, when you complete this lesson, you will be able to describe different types of scheduling with different scheduling algorithms. Therefore, the lesson would enable you to describe what is scheduling, explain different scheduling algorithms, list advantages and disadvantages of different scheduling algorithms. Okay. Right. Hope you all can hear me. Can you hear me properly? Just forget to check.
Yes, sir.
Okay. The screen also visible, no? Okay, let me share it again. Now you can read the letters, no?
Yes, sir. Yes.
Right. Good. So, introduction to scheduling. In a multi-programming environment, a number of processors exist. So, our operating systems, there are so many processors, sometimes hundreds of processors existing, right, in the main memory at the same time. Some of these processors may be waiting for an event. You can remember the block situation, waiting for an event to occur, while another may be using the CPU. One is executing the CPU, another one may be waiting for another event. In a situation like this, there might be a number of ready processors waiting for the CPU. So there are waiting processors to get access of CPU. Now we need the manager to select which one get the chance and so on. So that is what we call schedule. Therefore, a selection must be made among the ready processors. So when there are, for example, 10 ready processors, which one to select and give the chance? Right? Selection must be made among the ready processors to select the next process to run. The part of the operating system that handles this selection procedure is called the scheduler. The algorithms that are used for this are known as scheduling algorithms. So if you are designing operating system, you need to have a scheduler which one to select next. And there are many different algorithms for doing this. Now, process switching is expensive. Process switching means you switch between processors. For example, half a day you execute one process in the CPU, then give chance to another one. So there's a process switching part. When a switch from a user mode to a kernel mode is made, the state of the current process must be saved. So if you are stopping one process, you have to save all current status of that, because you have to restart it from where you stopped. And you have to save all the information in order to enable to load it back in a later stage. So that's why it is expensive. Expensive means you need more processing power and storage and so on. In other words, it is slowing down the machine if you switch very frequently. So after the next process is selected, these details must be reloaded into the main memory. Therefore, carrying out too many process switching functions may adversely affect the system. That means slow down the system if you are switching from one to another very often. So we need to reduce number of switching also. Consequently, scheduling algorithms must be devised in order to gain maximum use of the CPU. You can't keep CPU idle. Idle means without doing anything, right? You have to use it maximum to improve the system performance and thereby increasing the efficiency of the system. So if you always use CPU without keeping it idle, then efficiency will improve, right? At the same time, the user satisfaction of the system must be maintained as well. Not only the CPU utilization, but user side. If user is waiting for his application, it is not good for operating system. For example, if you enter password, username and password, waiting for 5 minutes for it to reply, it is not user satisfaction, not up to the satisfactory level, right? So you have to meet both. So depending on the type of CPU requirement and I/O functions, a process could be categorized as follows. Now processors, uh, two main categories, I/O bound processors and CPU bound processors. I/O means inputs, outputs, right? So most of the process time is used for waiting for I/O. Has short CPU bursts and frequent I/O waits. Let's say you are entering something to the Word document using keyboard. So when we press keys, it is comparatively very much slower than the CPU processing time. So to read the character from keyboard, then put into Word document, spell checking and so on. So they are more I/O bound, or you display something on the screen without much calculations. So they are called I/O. Only very little time they require from the CPU. Right? So short CPU burst, short time use of CPU, but mostly using for waiting for I/O. Right? On the other hand, CPU bound process means, let's say, so many calculations you have to do. So most of the time is used for computing. Long CPU bursts, so you need long use of CPU and rarely use input outputs. Okay, so we can have two types of processors. When scheduling is done, the type of the ready processors must be considered as well. Typically, if IO-bound process needs to run, it may be advisable to give it an opportunity quick. Now here, I think this processor's wrong spelling. These are not hardware. These are the we are talking about software processors. Yeah. This is not OR but ES. Okay, you can correct it in your notes. Should be like this. Ready processors. Yeah? CES. That means we are talking about the software programs, not the CPUs. Huh? So we schedule these ready processors must be considered. They are here. You can see IO bound process. This is the correct thing. Huh? Or CPU bound process. So IO bound process needs to run. It may be advisable to give it an opportunity quick. So when you schedule something, there's IO bound process. It is advisable give it an quickly. For example, we are waiting for user to enter username and password or PIN number, like ATM machine. Username and your PIN number. Then you have to give priority for that, right? But it may be slower until you press the enter key. But once you enter, you can't run other process and ask the user to wait. You have to give quick reply. So the scheduling decisions have to be made on a variety of instances. So when make decisions, we have to consider few things. Example, when a process is created, when a process exists, like termination. When a process is blocked, what to do? Waiting for an event. Or when IO interrupt occurs. So we have to consider those situations and make decisions. Now there are two main scheduling algorithms. I think last week we met this term preemptive and non-preemptive. Right? I briefly mentioned that. So you have to learn these terms. What is non-preemptive scheduling? What is preemptive scheduling? Non-preemptive scheduling algorithms. When this type of scheduling is carried out, no scheduling decisions are carried out during clock interrupts. So if it is non-preemptive, no scheduling decisions during clock interrupts. When a process is selected to run, the process has the option of executing until it blocks for IO or until it voluntarily releases the CPU. So you don't worry about clock interrupts. If you get the CPU time, you can run until you complete your task. Or for another IO block or something. Okay? So that is non-blocking or non-preemptive scheduling algorithms. Second type is called preemptive algorithms. So it is the other side of this. In this instance, once a process is selected for execution, it can only execute for fixed length of time until next clock cycle, clock interrupt. At the end of this period, the process is suspended. So there's a time slot allocated CPU time duration. Once it is finished, we have to suspend it. And another process is selected from the ready list. Okay. So this is known as preemptive schedule. Non-preemptive, you don't worry about clock interrupt. Therefore, in preemptive scheduling, a clock interrupt must be given at periodical intervals to give the control of the CPU to the scheduler. So scheduler, so you can beforehand decide how long the clock interrupt is. That means when you give a chance to one process, how long you allow, maybe milliseconds or something like that. Then to decide this, how long, also another decision. Okay. So what are the scheduling algorithm goals? So when you have to decide the scheduling, what are the goals of the scheduler? Scheduling algorithms must vary depending on the type of environment. So different types of requirements. The three main types of environments are as follows. So what type of purpose we are using the compute? Okay. So three such categories are batch systems. That means you select hundreds of or thousand batch and process it continuously. Right? That is batch process. Then interactive systems. Interactive, any example for interactive system? Like ATM machine or the game playing software. They are interactive. No? Batch system means no interaction. Overnight you can put like banking or insurance companies. So overnight processing, no persons involved. So similar jobs, thousands of similar jobs. Batch process. Interactive systems are user involved. So you may decide to give commands and so on. Then the third type, real-time systems like airplane simulators and so on. You need real-time processing or answers. Okay. So different application areas have different goals. Therefore, the scheduling algorithm must also cater to these demands. That means different systems, different purposes, you may use different algorithms, not the same algorithms. Okay. So let's take one by one. The batch systems. The main objective of a batch system, batch processing system, is to maximize the number of processes carried out per hour. Because we are sending, let's say, 100 jobs per batch. So we need to maximize the number of processes carried out per hour. That is called throughput. To increase throughput. So goal is to make it faster. The next is to minimize the time for submitting and termination of the process and reduce the turnaround time. Next, the maximum utilization of the CPU must be achieved as well. So these are goals of the batch processing. So normally we select like routine jobs, for example, salary calculation of a company. So all employees, there's a similar routines like how many leaves taken, you reduce that from the basic salary and like that. Right? So batch processing, we submit it as a batch because to reduce, loading and unloading time. So that is total time is called turnaround time. So one goal is reduce the turnaround time. Okay. Then also we have to maximum use CPU. That means, let's say you enter one job. Once it is finished, you get a signal. Then you enter another one. So in between, you are wasting CPU time if you try to manually enter one by. Instead, we put 100 jobs together, so we automate that. Once one job is complete, second job automatically go in there so that we can reduce the waiting time and increase the CPU usage. Okay, we can do it in batch processing. But if we consider interactive system, the goals are different, right? So main objective is to reduce the user response time. So when user waiting for something, quickly you should give that. Like using ATM machine, you can't ask user to wait for 5 minutes for a reply. So you should reduce the user response time. At the same time, the system must be able to meet the user's expectations and meet the proportional goal. For example, ATM machine, you have to make sure the accuracy of the money withdrawing and so on, right? So depending on application, there can be different goals. Then the third one, real-time systems. Okay, have different goals to meet. So what are the goals? Basic goal in these systems is to meet the deadlines. So real-time means there are deadlines. After deadline, no point of having results. Here to meet like airplane simulator, you must meet the deadline. Otherwise, there will be plane crash. Yeah? The other main goal is to maintain the predictability of the system. So many real-time systems we use predictions to speed up the process. Because if you can predict, okay, this is what going to happen next, you can load them before. Like search engines, when you are searching something, so there are intelligent search engines, they know what you are going to search next. Right? So even before you type, they will load that from internet to your computer. So when you search very quickly, you will get results. So that is using predictability of the system. If your prediction is correct, you can give very fast response. If it is wrong, of course, it will be slow. Hope you understand the concepts. If not, you can ask. Okay. So some basic goals must be enforced for all systems, irrespective of the type of environment. So common goals are there. Now we talked about separate goals for three systems, but there are common type of goals. What are they? All processors must be given a fair share of the CPU. You can't keep one process starving. Remember that dining philosopher problem? Yeah? Everyone must eat at least once a day, right? So all processors must be given a fair share of the CPU. So these are common goals here to keep in mind. Next, if a specific policy is maintained in a system, the scheduling algorithms must be devised so that these policies are correctly enforced. So you can make certain policies, but you have to enforce them. Make sure they are there. As an example, if we consider the different processors that could be executing at the nuclear reactors. computer system, right? So sometimes nuclear reactors, they are controlled by a computer system. In that case, what's the most important thing? Safety, right? So safety process, safety control process will need to have priority over all other types of processes, right? So depend on the application. So finally, the scheduler must keep a balance by maintaining all parts of the system busy, right? Uh, just checking whether in waiting to enter. Okay, looks no one is there. We can continue. Hmm. Are you okay up to now? So we can go for different scheduling algorithm. We start with batch systems. In the following section, a number of algorithms suitable for batch systems will be discussed. So when I say batch system, you should know we send number of jobs together, like 100 jobs we send to the computer. So like overnight processing, we send a batch. Okay? The computer is supposed to implement that. So the first one is first come, first serve. It is like if you consider queue, like if you go to canteen, right? So that is the first come, first serve basis. Last come, serve last, right? So one after another in a queue. That's the concept. So in this method, single queue is maintained for all processes. Whoever comes next must join the end, at the end of the queue. When a process arrives while the CPU is free, right? So when you go to the canteen, the Mudalali is free, right? So you can directly buy your item if it is free. So it will start execution. Okay. Then process can run till it blocks for IO or till the end of execution. So first one enter to the CPU can run until it blocks for IO or till the end. If the process blocks, what will happen? It is put at the end of the queue and the process at the beginning of the list is selected for execution. So in case if you are blocked, you have to join again in the at the beginning of the list, right? That means end of the queue. Sorry, you join if block process, you put at the end of the queue and select the one at the beginning, selected for execution. So any place there's a queue like bank counter, something like that, right? So normally it is very simple algorithm, right? Easy to understand as well. Easy to understand, and it is easy to understand. You know, it is easy to program as well, right? When you write programs. So irrespective of the simplicity of this algorithm, cannot be considered as an efficient system. Even it is simple, it is not efficient. Why? As an example, if there is a number of IO bound processes and a single CPU bound process in the process list, right? So let's say you have 100 processors, only one CPU bound. All the others are IO bound. So it will be more efficient to execute the IO processors first. But the scheduler using first come first served has no way to identify this because you are following the same order in the queue. You do not differentiate whether it is IO bound or CPU bound, right? So you can't give priority. It is something like in a supermarket queue when you want to pay the bill. Sometimes people bring full of trolley items, and maybe you have gone. You want to buy 2 or 3 items, right? So if 5 such persons in front of you, and after another full of trolleys after you, right? Well, for you it is unfair, right? You are waiting until others finish just to buy 2 or 3 items, but they are buying like 50 items per person. So you are unnecessary waiting. So this is a disadvantage in first come first serve uh, uh, method, even it is simple. So that's why sometimes supermarkets, when there are many counters, you can see faster counters. That is, persons only buy less than 5 items can go. Others must go to other queues, right? So that way you can improve it. But you have to understand this problem. You can't give any priority because you are following first come first serve. So there's a shortcut disadvantage. Then there's another algorithm. I think first one easy to understand. And let's see that this algorithm called shortest job first. So what we are talking is when there's a large number of people waiting or processors waiting, which one to give the chance, right? This may be a even a hospital, channeling center. So people are waiting. So to whom you should give chance, okay? So the second algorithm is shortest job first. So name indicates you have to select the shortest time consuming job and give it the first chance. So faster ones can go early, right? So in this algorithm, the runtime of the processors are known to the scheduler. So scheduler must know what's the runtime of each job. Therefore, the scheduler picks the process with the shortest execution time. Let's say now process A has this is the time required. Unit 8 units, maybe 8 seconds. Okay. Then process B 4 seconds, 3, 4 seconds, and so on. So an example for shortest job first scheduling. A represent jobs running in the original order. So if they run in the original order, A, B, C, D, right? So, but if you apply in the B, running them in short job first order algorithm. So if you apply this algorithm, you have to reshuffle them like this. So longest one you put at the end there, right? So you give chance for this give chance for B first, then C, then D, and later the A. Right? So this is different from the first come, first serve. You select, you sort them in the order of time duration requires. Okay, so that is another algorithm. So let's consider the above example 931, this diagram, where the process A, B, C, D exists in the process with runtime 8444. Okay, first like this 8444. The scheduler execute B, C, D processes before selecting process A. But this method will only be available if all the processes are available simultaneously. So you can apply this method if all in the queue, not arriving one by one. Right? Even though process with less execution time arrive into the system when a previously selected process is executing, scheduler has no way of identifying this. So we are not thinking about arriving process in detail. Okay. So that's the name, shortest job first. Then another algorithm is we can select shortest remaining time, not the total time, but remaining time. Remember, when you execute processes, some processes execute half a day and waiting. So you have to calculate the remaining time. So based on that, you can schedule. This method is introduced to overcome the disadvantages of the shortest job algorithm. So the algorithm, there's a disadvantage. It is preemptive version of the shortest job first. The runtime of the processes are known in advance. So this is the condition. Runtime of the processes are known in advance. When a new job arrives, the runtime of the new process is compared with the not the total time but remaining time for the running processes. So if one process execute one quarter, you take the remaining 3 quarters, right, to compare with the new car, the time. So if the new job requires less time, the whole process is suspended and the new process is loaded. Are you okay up to now? Is it clear, this one? Since I can't go, I can't explain this properly. Probably, yeah. Next lecture, what is today? 19th. So next week, 26th, we are not going to have lectures. Okay, I'm not conducting lecture next week. And after that, I think we can meet at the university. You got the news that we are going to allow students to come from next month. 2nd of September, you are supposed to come for the lectures to the university. So if so, I can use the whiteboard to explain these things. Maybe then a bit easier for you to understand, right?
That's better, sir.
Yes, these are sometimes difficult to understand just by the text. Anyway, just try to go through and get an idea. If it is not clear, next time I can explain. Okay. Then there's another scheduling algorithm called tree-level scheduling. Let's see what it is. Three levels. In a batch system, scheduling is carried out in three different levels of the system, like explained here. Now, here you can see arriving jobs into a queue. So there's a scheduler to control the admission and to load to the main memory. Then memory scheduler is there because if memory is full, you have to put to hard disk and get some and so on. So memory scheduler should be there. Then CPU time also limited. You have to divide it into between different processors, different jobs. Therefore, CPU scheduler is there. So you need three schedulers. Okay. Schedulers are like managers. So you need three managers to manage. Manage incoming queue, manage memory and hard disk, the memory scheduler, and the manage your CPU time. Right? So you have different schedules like your timetables and so on. Right? We need to have a schedule, lab schedule, classroom schedule, and so on. So when a job arrives, it is placed in the input queue. So when a job arrives, it is put in a input queue. So then admission scheduler will decide who will enter depend on the algorithm used. So job arrives, it is placed in the input queue. Next, the admission scheduler selects process for admitting into the system. Right? Typically, a mix of CPU-bound and IO-bound process may be selected for admission in a given instance. So it depends on whether CPU-bound or IO-bound. Admission scheduler, you can program which one to give next chance. Afterwards, memory scheduler checks the size of the processors and decide process to kept in memory and process to be swapped out to disk. So when you enter new one to the memory, you have to find space now. So you have to decide which one to put back to the hard disk and make some space for newcomer and so on, right? So you need algorithm for that. So it is handled by memory schedule. Checks the size of the process and decides process to be kept in memory and process to be swapped out to disk. The scheduler may have to review the process periodically. So scheduler may have to review the process periodically, ensure that the process swapped to disk will serve as well. Because you can't keep a process in the hard disk without giving chance to execute in the CPU, right? So you have to double check time to time, recheck. Finally, the CPU scheduler is responsible for selecting a ready processing main memory to execute next. So it may use any of above methods, either preemptive or non-preemptive algorithms could be used depending on their suitability. Okay. So far we talked about batch processes. Remember we started three types of processes. Batch systems, interactive systems, and real-time systems. systems. So far, I have explained only batch systems. Then we see the second one. Batch systems means you get jobs in a batch. Like input queue, you get 10 jobs at once. So you can schedule. But interactive and real time are different from these. So you can't apply the same algorithms for uh, this second one. So let's talk about the second one. Interactive systems. Okay. So in these systems, two-level scheduling with memory and CPU scheduling is used. A couple of CPU scheduling algorithms is discussed in the following section. So interactive systems like game playing or the ATM machine, it's interactive. No? So these two-level scheduling memory and CPU. So we'll see few CPU scheduling algorithms for interactive systems. One is round robin scheduling. So this again very easy concept. We consider it as a round or circle. Right? Round robin scheduling scheduling a single list of process is named like single queue. All processors are granted the CPU for a specific time interval called the quantum. Right? Time interval is known as the quantum. So each process you give one quantum. Once it is finished, you give the second process another quantum. Then third process another quantum and the same order. So you can go around like a circle. Right? The context switch is made at the end of the quantum. So it's like clock cycles. So end of the clock cycle, you have to do some switching. What is switching? Current process is suspended, so you have to save. And the next process on the list is selected to run, right? So that is known as context switching. Okay. So this algorithm is one of the simplest, very easy to understand. Fair because everyone getting a chance. And this is widely used algorithm in operating systems. Okay. Can be easily implemented, but there are disadvantages. Due consideration must be paid when setting the content. So what's the clock cycle time content? So you have to give due consideration because if it is too long before the content, one process may finish and CPU is idle. What will happen if it is too short? Too many context switchings. Yes, you give only little bit of time, then switch into another, right? So how to select the clock time or the content? Since this could directly have an impact on system performance. So it's very important to select the correct content or the time duration for clock cycle. But otherwise, it's very easy to implement and easy to understand. Then another algorithm. So earlier one very fair for each one. But in general, you can't have fair solutions, right? When high priority processors comes, you have to give high priority. Like our political systems, when a minister or someone, prime minister, president comes, you have to give the priority than others. Even road, you have to give clear and give access because high priority. Right? The computer systems also like that. So priority systems in this method, each process is assigned a priority. When selecting a process to run among the ready processors, you select the highest priority one and give the chance. So you check the queue, check the highest priority and give them the chance. Okay. Since low priority processors might not get a chance, so this is the problem. If we apply this, low priority processors might not get a chance. Start. You have to avoid that problem in this circuit. The priority of the currently running process is reduced at each clock interrupt. So what you do is when you give chance to a process, you reduce its priority. So if it blocked and put it to the queue, it is a low priority. So like that, each time it is getting priority reduced, so others also get a chance. Right? So at each clock interrupt, you can reduce priority if it executes. So when this causes the priority of the current process to drop below the next highest ready process, the context switch will occur. Process may also be assigned a specific time quantum to run as well. So clock time also you give the quantum. Priorities may be granted statically or in dynamic manner by the system. Priority while executing also you can change the priority. Okay, so I think that's all. No, one. Another method is not only one queue, but you have multiple queues. So in this method, priority classes are designed. So you put queues according to the priority, right? Each with different priorities. Different time quantum is assigned for each priority. As an example, priority 1 may have a time quantum of 1, right? Priority 2 will have quantum 2 and so on. So high priority, priority 4, once it get a chance, you get 4 time slots for that, so that it can finish before block, because they have high priority. Okay. So separate queues are maintained for each priority. Preference is given for the highest priority queues. For example, if there are processors priority 4 queue, all those processors are executed for the allocated time quantum before considering the processing priority 3 queue. Okay. When a process enters the system, it is granted priority 1. So initially you granted priority and runs for 1 quantum. If it doesn't finish during the allocated time, it is suspended and granted priority 2. That's the idea. So initially you give priority 1, and once executed and blocked, you give priority 2 because it gets higher chance and finish it off rather than new ones. Okay. So multiple queue system was designed to reduce the overhead incurred for frequent context switching. So you can reduce number of switchings and to prevent starvation for process. So it can avoid the starvation problem also. Starvation is not getting any chance. Okay. And there's another type of algorithm. These are different methods you can implement. Okay. Next time you can design your own algorithm as well, for your operating system. So this one is known as shortest process next. In this algorithm, an estimate of the runnable time is made by considering the past execution data. So you have to estimate the runnable time of the process. You can use previous data statistics to estimate them. Once the runnable time is estimated, the process with the shortest time is selected for running. Okay. So process with the shortest time is selected for running in this method. And there's another method called guaranteed scheduling. So I'm describing different types of schedulings. Okay. In guaranteed scheduling, a real promise is made to the users about performance and actions are carried out to live up to them. For example, if n users are logged at a given time, each user will be given 1 divided by n of the CPU power. Right? So if you have one CPU, 10 jobs entered in the queue. So 1 over 10 CPU time you can give to each process. So this is known as guaranteed schedule. In order to carry out this system, the system must keep track of how much CPU time a process has used since its creation. So you have to maintain the history. Afterwards, it computes the amount of CPU power the process is entitled to, time since the process was created, divided by n. Next, the ratio between actual CPU consumption and the entitlement is calculated. Finally, the process with the lowest ratio is selected for execution. So that one, there are some calculations you need to make. So that is about interactive systems. Okay. So we have another system, that is the third type, called real-time systems, like flight simulators and so on. So we need different types of algorithms for real-time systems. Why? Unlike batch or interactive systems, in real-time systems, time plays an important role in real-time systems because you have to meet deadlines. Example of these types of systems are patient monitoring system in a hospital, like ICU, right? So patient monitoring system in a hospital, or autopilot in an aircraft. So you can see how serious they are, right? So you must act real time when there's a problem. You can't give excuses. You can't give excuses, right? You must act. Like ICU, when there's a heart failure or something, you must act quickly, right? No excuse. So these are known as, you have to act real time, okay? Real time systems. But other two, you can wait. You can allow process to wait. But here you can't allow important process to wait. Okay. So keeping that in mind, let's see what kind of algorithm. So real time also you can divide it into two. One is hard real time. Absolutely all deadlines must be met. Otherwise, person will die. Right? So they are hard deadlines. You can't change. But sometimes, certain cases, we put soft deadlines. That means missing an occasional deadline is tolerable. Something like I give deadlines for your assignments. So one or two students I may excuse due to different reasons and give some more time to submit. So it is not hard. But when we come to exam, you can't tell I'm late for exam and give me some more time, because it's a hard deadline. You can't change the exam time, right? But if it is soft, sometimes we can make it flexible, right? I hope you got the idea. Then in real-time systems, the runtime of all the processes are known in advance. So real-time process, we know the runtime of the process, how long will it take. They are generally short-lived with a well-known behavior, right? So we know they are very short-lived. Therefore, when an interrupt occurs, the scheduler must make sure to schedule the process and meet the deadline. A real-time system will need to respond to different types of events. One is called periodic events, occur at regular intervals. Another one is aperiodic, that are unpredictable. So once in a while, it will occur. If perfect information about process is available in advance, right, and deadlines have to be met, a real-time system can use static scheduling algorithms. So if we know these are the processes available, these are the time constraints, we can have certain scheduling algorithms. In this method, scheduling decisions are made before the system starts running. So we can make the schedule earlier before system starts. But in contrast, if this information is not known, then there are going to be a problem. Dynamic scheduling will be used. So we have to change during runtime. Okay. So that's it. I have described many different algorithms, explained different scheduling algorithms which use in a batch system. In your words, that's kind of exercise. Anyway, I know they are a bit difficult to understand them all at the same time. So you may read them slowly, and if you have problem, then ask. Probably our next lecture in 2 weeks time. So next week, no lectures for operating system, right? If you want, you can reschedule another lecture. Okay?
Okay, sir.